Now, welcome to today's class. Today, I have an amazing lesson concerning probability and statistic 2. Specifically, I want to cover some three major areas. That is, how to get the median of a continuous random variable. Then, after that, we shall be looking at now how to get the upper and lower quartiles of the same continuous random variable. And lastly, we shall be able to look at how to get the median of a discrete random variable. Now, to begin, I want us to consider the above equation. You've been asked to find the median of the following PDF. The function is that is fx is equals to the provided function, that is 3x squared. We have a range provided there, 0 or elsewhere. Now, in case you've been provided with such a question, then you are asked to find the median of the above function. I want to show you the best and easy approach that you need to apply concerning the provided question. Now, let us look at the solution here. So that is the solution. That is the solution. Now, in case you are getting the median of a continuous random variable, the first thing you need to put in place is that you must ensure that you have an idea of integration. That is it. So what you need to be doing is just to come and write the provided formulas. Probably we have two formulas and I want to show you them. So the first formula is just put the integration sign, then at the upper limit write m. So m there is the median. So once we shall be in a position of getting m, already we shall be in a position of getting, that is the median. Then since m is at the upper limit, meaning the lower limit can go as far as negative infinity, because we can't estimate the exact value of the lower limit. So here we shall now come and say it is negative infinity. Then after that, just write the function there. The function is 3x squared. Just come here and write the function. And what was it? Fx. So since I am giving you the formula, instead of writing the function here, I'll write fx. So that is fx. And since we are integrating in terms of x, we shall now write that is dx. Now this is the first approach. Now the second approach should be the same as the first approach, and therefore we do equate the two. So the second approach here, you require you to just put the integration sign that way. Then now what will change is the upper as well as the lower limit only. The rest are just the same. So here, instead of us putting m as the upper limit, it should be now at the lower limit. So at the lower limit here, you are required to write m there. Then after that, since m is at the lower limit here, that one means that the upper limit can go as far as infinity. That is it, because we can't estimate the exact value of the upper limit. So you just come here and write that is infinity. Now after that, since it is a median, we do assume that it is a half. So we do just equate it to a half. And therefore, I told you that what will change is just the limit. Just write here fx, and since we were integrating in terms of dx, just put dx there. Then everything should give you that is a half. Now after that, you are required now to use whichever method you intend to use. You can use the first one, equate to a half, or the second one to equate to a half. Now in case we want to use that is the first one, so consider the first one, and the first one is that is integration of m negative infinity fx dx is equals to a half. I want to use this so that you will apply the same on the second approach. The answer will be the same. That is it. So now let us look at it now. Fx now is the function here, and it is 3x squared. So where fx is, we shall write that is 3x squared, then the rest are just the same. So you will put an integration sign that way, then m negative infinity there, then 3x squared dx, because we are integrating in terms of that is dx, is equals to that is a half. Now after that, your work is very simple, because you are just required to integrate 3x squared, and when you do so, what you are required to do, just add 1 to the power. So when you take 2 plus 1, probably 2 plus 1 is a 3, so you will have 3x cube, then you divide by the total power, which is 3, and therefore you will end up having something like 3x cube over 3. But remember to write the limits. The upper limit was m, while the lower limit was negative infinity. The whole is giving us a half. So that is that. Now after that, you can see something very unique here, whereby these 3 can cancel there, so that you remain with the rest, that is x cube, with the limits, the same limits, that is negative infinity there. The total is a half. Now after that, you are just required to substitute for the first case x with m. That is it. Then for the second case, you are supposed to substitute with the lower limit. So let us begin with the upper limit. So substitute x with m, it will be, that is m cube minus, now when you come to the lower limit here, it is a negative infinity. Now here, negative infinity, we do assume that it is a 0, because they are just the same. So instead of us using a negative infinity, it is better to use a 0, because they are just the same. So I'll just come here and substitute x with 0, and when you do such, it will be 0 cube there, and the total must be equals to a half. Now friends, when you look at here, you realize that 0 cube is just 0, and therefore you shall just remain with m cube. When you do such, you will just say m cube is equals to a half. Now after that, you can as well get m, because that's my main area of concern. So how can I get m, since it is m cube? By just getting the cube root, just getting the